Hi, in this video class, we are going to study the process spectrophotometry. We know that each and every particle or each and every solute can able to absorb a specific wavelength of light. For example, chlorophyll A, it can able to absorb wavelength ranges from 380 nanometer, 700 nanometer, like that. Each and every particle can able to absorb a specific wavelength of light. So, spectrophotometry means it is a special technique used for identifying and detecting, or quantifying a specific material in a solution by analyzing its absorbance value of a specific wavelength. I already told you that each particle can able to absorb a specific wavelength of light. Suppose if you imagine particle A can able to absorb 680 nanometer wavelength. Suppose if you imagine this sample solution contain particle A. Now I am giving a wavelength of 680 nanometer. While I am giving 680 nanometer wavelength into this solution, that wavelength will, more amount of that wavelength will absorbed by that particle A. It indicates that that particle is A. This particle is A. Because a particle only can absorb 680 nanometer in more amount. So if this solution grasp or absorb more amount of 680 nanometer, it indicates that that is a particle A, named as A. So like that, spectrophotometry means it is a special technique used for identifying and quantifying the concentration of a specific material, specific solute in a solution by utilizing its absorbance value of a specific wavelength. That is called spectrophotometry. For that purpose, for identifying and quantifying a specific solute in a solution, we can depend an instrument. That instrument is called spectrophotometry. Spectrophotometer. So spectrophotometer is an instrument which is used for this purpose, which is used for spectrophotometry. Now let us try to study what are the different parts of spectrophotometry and also what are the different mechanism, what are the basic mechanism which are working behind the spectrophotometer. First of all, you can see a light source. This is the first part of spectrophotometer, light source. Second part is called the collimator lens. Third part is called a prism. Fourth part is called wavelength selector, and fifth part is a sample cuvette. It's a rectangular small. It is a test tube like, it's a instrument, it is a material like a test tube. That is sample cuvette. A cuvette which is used for loading sample. Detector and a digital display to see the readings. So here, first of all, light source. The main function of the light source is to generate light with a different wavelength. You can see here light with different wavelengths. And second one, collimator lens, receive all the light with the different wavelengths and direct that light into the prism. The main function of the prism is that it distinguishes or it separates light waves. It distinguishes or separates light with the different wavelengths and allow them to move in different paths. So prism allow light with a different wavelength in different direction to pass. So after that, all those light with a different wavelength reach on the wavelength selector. This is the key parts of the spectrophotometer. Because after wavelength selector, you can see a cuvette. It's a beaker, like it is a test tube like structure. Within that cuvette, you can see the sample to be tested. So this wavelength selector never allow all those wavelengths to pass through it. It allow only selected specific wavelengths of light through the sample cuvette, because if I need to know the chlorophyll A molecule present in this sample, suppose if you imagine this sample contains chlorophyll A solution, then this wavelength selector allow only those wavelength which is most probably absorbed by this chlorophyll A. So wavelength selector only allow the movement of those wavelength which is most suitable for the sample solution which is going to be tested. So wavelength selector allow only those wavelength which is most apt or suitable to test the sample solution. So that wavelength, that light is called incident light, that is called I0. Suppose this incident light is moving through the sample solution, the material which is to be tested will absorb this incident light. So the resultant transmitted light, is normally lesser than the incident light. Okay. By using the absorption capacity of this incident light, by using the absorption capacity of the testing material, by using the absorption capacity of this unknown material, we can able to say that this unknown material is type A molecule or this unknown material is type B molecule, because we know that this incident light, we know the wavelength of this incident light. Suppose if you imagine the wavelength of this incident light is 680 nanometer. Suppose if you imagine this incident light wavelength is a 680 nanometer. If this unknown material absorb this 680 nanometer wavelength, that is I0 in more amount, we can say that 680 nanometer will be absorbed mostly by chlorophyll A. So it indicates that this unknown material is a chlorophyll A. So here we are using non-wavelength of incident light to identify and quantify the unknown material. That is the concept behind. So here we need to understand or we need to study what is absorbance. Here identification and quantifications are done by the absorption value of this unknown material. So we have to find out the absorption value of this unknown material. Okay, that absorption value can be detected by this digital display. So this is the concept behind this spectrophotometry. So here we need to find out absorption value. This is a mathematical equation for absorbance. Absorption is equal to absorbance value. Absorbance value, that is A is equal to log A by T. Absorbance value A is equal to log 1 by T. Log 1 by T. That is log 1 by transmittance. Absorbance A is equal to log 1 by transmittance. That is absorbance is equal to log inverse of transmittance. So here we have one unknown value, that is what is transmittance. How much quantity of incident light get transmitted? So before going to find out absorbance, we have to find out how much amount of light get transmitted. That is without absorbed by this unknown material. So first of all, we have to find out what is transmittance. T is equal to transmittance IT, transmitted light divided by incident light. That will give you the amount of light transmitted. Total amount of transmittance is equal to transmitted light divided by incident light is equal to transmittance. If we find out transmittance, then we have to substitute the transmitted value here. So absorbance is equal to log inverse of transmittance. So this is the mathematical equation to find out the absorbance. So here we are utilizing the absorbance value of a specific unknown material to identify its presence and its quantity. This is the concept behind the spectrophotometry. Thank you. Okay.